Hi, welcome to Advanced Math, Trig Identities, Part A quiz recap. Part A quiz was just a one-question homework quiz oriented around the questions that were on the homework for Part A. And the recap isn't going to go over the question on the quiz. We're going to go over a question that's very similar. So if you've taken the quiz, this should look familiar. If you haven't taken the quiz question is different, but maybe this would be enough to help you get through it. So the question that I've written here is the question from the quiz. I'm not going to do that one. I'm going to do something different. So let me write down the question that I will do as an example. Cosine of A times cotangent of 90 degrees minus A. That's the one we're going to tackle. So one of the things we want to do in simplifying trig expressions is reduce it if possible to functions, a single function, for example. And we favor the cosine, the sine, and the tangent functions when possible. And if we have arguments to a function that are, say, complicated, like 90 minus A is complicated, we want to see if we can eliminate those as well. And for this one, what we want to remember is that all of the functions, if you are passing into the function the complement of an angle, which is what 90 degrees minus A means. 90 minus A means we're going to take the complement of A. Every one of the trig functions, if you pass in the complement of an angle, that's equivalent to the co-function of the angle itself. So that leads us to the very first step that we can take with this one, which is to transform the cotangent of 90 minus A, or the cotangent of the complement of A, into simply the tangent of A. And I'll leave cosine of A as it was. So we've changed, in one step, changed this from cosine of A, cotangent of 90 minus A, to cosine of A times tangent of A. Now, again, trying to get down to as few functions as possible. Two functions here, cosine and tangent, is pretty good. We have one more trick up our sleeve, which is to remember that the tangent of an angle is equal to the sine of the angle over the cosine of the angle. Right? And that could be handy. So I'm going to apply that idea to this situation. We're going to apply that to this part of the expression, the tangent of A, and we're going to use this identity to rewrite it. And in so doing, we are temporarily making this more complicated. But that's by making it more complicated, we are introducing opportunities to cancel. And when we do this, we don't necessarily know that those opportunities are going to arise, but we try it. So very often the act of simplifying a trig expression is one of trial and error. So I'm going to rewrite this on another line. I have cosine of A, which I've been carrying with me all the way through so far, and the tangent of A is now sine of A over cosine of A. One thing I'll take this opportunity to point out is that our identity that we're using here is tangent of theta equals sine of theta over cosine of theta. We're using that idea, this relationship between tangent and sine and cosine, to transform tangent of A. Now notice the argument to the tangent function is A, and we are now transferring it to sine of A over cosine of A. So the use of the theta as an argument is completely arbitrary. Theta is a traditional variable used for angles, and in this particular example we're using a variable called A. And so we just use A instead of theta. So tangent of A became sine of A over cosine of A. Now, we've got a thing, cosine of A multiplied by a fraction. So, for multiplying fractions, of course, we multiply across, and if we don't have a fraction, we can turn it into a fraction so that we can multiply across. Before I go multiply, cosine of A times sine of A isn't anything special. But I do have a situation where, essentially, I've got, let me rewrite this a little bit. So this is absolutely clear. I'm going to introduce the parentheses again because I'm trying to be consistent here. Cosine of A times sine of A. That's the numerator. over cosine of A. That's what I end up with by multiplying that together. Now at this stage, the numerator has two factors, cosine of A and sine of A. And the denominator has just one, cosine of A. And cosine of A matches one of the factors in the numerator, which means, yes, we can cancel it. And so that will just equal sine of A. And that's as simplified as that's ever going to get. So let me draw a circle around that. Yes, that's a simplified statement, a simplified expression that's equivalent to what I started with on this example. Now, you could go in a slightly different direction, and I want to show you that over here. So notice that I got in my original example cosine of A, and I've got cotangent of 90 minus A. One thing you could do is you could, instead of going as I did here to all the arguments being A, I could go to all the arguments being 90 minus A. Now, normally that's not the direction you go in. You don't want to go to arguments being more complex, but hey, let's just illustrate how that would work. So remember, cosine and sine are cofunctions, and if I have cosine of A, that would be equal to the sine of the complement. So this would be equivalent to, this example would be equivalent to sine of 90 degrees minus A times cotangent of 90 degrees minus A. And at that point, I can use the identity for cotangent, which says that cotangent, I'll write that up here on the right, cotangent of theta is equal to cosine of theta over sine of theta. And this identity is very similar to this one for tangent, except that this fraction is the reciprocal of that fraction. So tangent of theta and cotangent of theta are reciprocals of each other. So let me rewrite this again as the sine of 90 degrees minus A times cotangent is cosine over sine, so this would be cosine of 90 degrees minus A over sine of 90 degrees minus A. And I'm going to extend the bar for my fraction over there, because really when I multiply this single thing on the left by this fraction, I'm going to get, just as I did doing this, turned into this fraction. I'm getting a single fraction with two items in the numerator and one in the denominator. And as I did in the last example, I see that one of the factors in the numerator matches my denominator. So this and this cancel out again. And that leaves me with simply cosine of 90 degrees minus A. Now, that's not wrong. That's a statement. That's an expression that's absolutely equivalent to what I started with. But is it fully simplified? No, not quite. Because I've got the complement of A in here, I can rewrite this as the cofunction of A. And the cofunction of cosine is sine. So this is just sine of A. And that would be the fully simplified form. And of course, you can see that it is the same as the one we got the last time, sine of A. Okay, so this process that I used here is very similar to the one that you would use to simplify the original expression. So I leave that one for you. Thank you.